This class is mostly focused on the foundational technologies that have built up to what we now consider the modern web. We don't go very deep into modern web programming, and we don't really spend time with really cutting-edge web technologies. We're sticking with the tried and true ones that are very much still in use today, but aren't as, well, sexy as some of the more advanced techniques that are being used nowadays and advanced tools. These days everybody talks about things like Node.js and React, and these sorts of tools are very powerful but also incredibly complex. So they're well outside the scope of the things we would want to approach in an early level class like this. However, as we get ready to say goodbye to JavaScript, we're going to take a look at the technology that is arguably the foundation of all of those things. It is perhaps one of the more popular buzzwords when it comes to web programming, and it leads us to a really simple idea that only takes a little bit of practice to get used to, that when scaled up and put together in larger pieces, becomes a very powerful tool for designing what we would call single-page web applications. You've used these all the time. All of the Google Documents tools are single-page applications. Facebook is a single-page application. Twitter is a single-page application. These things show you lots of data and you traverse through different bits and pieces of it, but you never actually leave that one web page. The page updates dynamically as you're working through it. Now, the technology I'm talking about is most generically referred to as AJAX. AJAX is an acronym. It stands for Asynchronous JavaScript and XML. And in fact, the acronym actually isn't even accurate anymore. The X is no longer used, the XML. So we want to establish exactly what we mean when we say asynchronous, comparing that with synchronous communication. This is essentially talking about how a client and a server communicate with one another. Only now, the server is going to be responding with something other than a full web page. It can respond with data instead. That data can basically represent a partial page. And most often we'll see that data encoded as something called JSON, which stands for JavaScript Object Notation. Ultimately, when all of this comes together, we use a new object inside of JavaScript, which is called the XHR, or the XML HTTP request, and that's when we will be doing true AJAX communication. So we need to establish sort of the foundational ideas here. What does it mean to behave asynchronously? And what does it mean to only receive data rather than a full web page? So we'll begin with that. So synchronous versus asynchronous. You probably have some idea about these concepts. These are not ideas unique to computer programming. All of this has to do with two people working together, two or more, and whether or not they wait for one another to complete what they're doing. Is there really just one thing going on that they're all taking turns to participate in? Or are there many things going on at once, and everybody is sort of in their own world, sharing information, but also undertaking their own processes? So we've talked before about client-server model, and we've basically been talking about it in a synchronous sense, which is to say that the client and the server always stay synchronized, executing one single task together. They never go off on their own to do anything by themselves. Now, of course, there's a bigger picture. The server is actually serving many clients, so the server is doing a lot of other things. But the only things that the one client and the one server are concerned with is that one transaction. And that transaction is something that happens synchronously. So the client begins by sending a request to the server. We've talked about this before. It sends an HTTP request to the server. It then waits. And time goes by, and it continues to wait, and it usually becomes unresponsive. You can't really interact with the page, or you're even sometimes shown a little waiting icon. Now, most of the time this goes by so fast it doesn't bother you, because servers are, at least for most of the things you do day to day, the servers are very expensive. There's actually many of them distributed across the United States or around the world. They respond very quickly, and they give you back your answer before you've even noticed you were waiting. The response is received by the client renders that response. Now, when we say renders it, that means it loads the page, and it draws the page for you. So the request was sent maybe by you typing in a URL, maybe by you clicking on a link somewhere, and then a whole new page is given back and loaded. That's usually how this works. Let's look at this another way. We can sort of plot this over time here, what this looks like. So the user, the client, we really should say, it decides to view a page, and some sort of event happens. This is usually, typically, they click on a link. At that point, the event in the form of an HTTP request gets sent to the server. The server generates their response, usually a web page, and then sends it back to the client. Now, all of this time right in here was dead time, during which, in order to remain synchronized with the server, you are not allowed to do anything. No future events can occur. You can't click on anything, though you'll find in some web pages you could actually click on something, but doing so is going to cancel this, and it'll just start a whole new one. But very often, you are just forced to wait until the new page is received, and then that page gets rendered, and then you can create another event. This is the synchronized model. It happens so often we don't even think about it, and these days it happens pretty quickly, so we don't really have to worry too much about the fact that we become we play the waiting game in between. However, part of what's problematic with this model is that sometimes we don't need a whole new web page. Perhaps all we needed to get from the server was a little bit of data, and we'd rather just say to the server, hey, tell me a little bit more about this. We get that back, and instead of re-rendering a whole new page, we just like to update the current page we're on. This sort of partial communication becomes crucial, and rather than having these big sort of grand events where we ask for a whole web page, we wait for it to come back, we render it, we would have lots of little events. Now, this has all kinds of implications on the server technology. Servers have to be a little bit different in order to be good at that, as opposed to this big grand waiting kind of thing. But we aren't going to worry about those kinds of implications. That's for people who deal with servers to figure out. People that are in the CNIT program would be the kinds of people that would be concerned with how different the server needs to be to handle those lots of small requests instead of a few big requests. So, what happens to this picture when we think about it asynchronously? Again, the concept here is just that while there are two people involved, these two things are allowed to do their own thing. They can still communicate with one another, but they don't wait on each other. They continue to work, and they both do work at the same time. This becomes complicated when they have shared resources, and the communications that go back and forth between the client server are just that. I send some information to the server, I wait for it to send me something back. Now, the client-server relationship is segregated enough, in fact they're two completely separate computers most of the time, that we don't really have to worry too much about really low-level shared resources, like, say for instance, shared memory, or both of them trying to share the same keyboard or something like that, because they're completely separate computers. They have their own sets of hardware. And so this kind of becomes an ideal environment for them to just work on their own. It's also completely feasible that the client, or rather the person using the client, is just doing multiple things, several of which the server's not concerned with. So, what this begins to look like is, again, we still start by sending out a request. And I'm going to call this request 1, because we're going to have multiple requests this time around. And then the client can just keep right on going. It doesn't wait for the response. It sends a second request. The server then, over here on the client, remains responsive and happy. I could keep interacting with my web page. I can keep generating more requests if I wanted. And things will just keep going, because instead of blocking and waiting for the response to these and assuming that I can't do good work until I get the response, I just keep going. The server then eventually responds. It sends back response 1. And now the client makes some sort of update, typically small, to the page based on the data that it received back. And then finally, server responds with the second response, whatever the request 2 asked for. And again, some sort of small update happens to the page as a result of that. So this is a fairly straightforward idea. This is really how two active people that exist over time would interact with one another. They aren't going to just shut down while they wait for the other person to talk. They're going to actively listen and engage. This has very deep implications when it comes to programming subtleties. But in the sort of internet client-server relationship, a lot of those subtleties are not things we have to concern ourselves with. There is, however, one thing you should always keep in mind. Notice here we sent request 1, we sent request 2, we got back request 1 first and back request 2. So our responses came in the same order as our requests. That does not necessarily happen. So now a lot of times it will, if request 1 goes out, you can expect the answer to request 1 before the answer to request 2, but you cannot guarantee it. The server may be able to respond to request 2 sooner, and so if it was a short request, maybe you get that back right away, whereas it takes a long time to generate the response for request 1. So you have to think about that. And you can see here, one thing you might do is that if you get response 2 before response 1, you'll delay your update. You'll wait, because maybe the info from response 1 was important, and then once you've got both of them, you'll make the updates. We'll never get ourselves in situations where we have to deal with that. But it is important to point that out now, that as soon as you do go to asynchronous communication, there's a potential for that your responses will arrive out of order. Let's look again at this sort of timeline version of it. They have Ajax in the middle here as being the sort of glue that makes all of this happen. That's very true, though it's a little more subtle than this. Ajax is inside of the user's computer. It's not its own separate thing. It's part of JavaScript. So the key thing to recognize here is that as we go across the top here on this one, we're never in waiting mode. That's what this sort of dotted line is. The user is constantly able to interact. They can keep doing things. So they generate the first event. This is like request 1. It comes down and reaches the server, and it's got to generate its response. In the middle of that, we actually generate the second event, and the server's processing that as well. Here, they get the response to 1 back first and then to 2 back second. But you could see it's entirely possible that if this one took longer, its response would come back after it had already responded to the second thing. So keep in mind that that is a possibility. And this can go on forever. The page is never blocked. When the results are received, we don't just refresh the entire page and re-render it. Instead, we are now responsible for using that data in some sort of effective way. You really can't do Ajax until you know how to modify the page from JavaScript, because we're going to receive that response in the JavaScript and then have an opportunity to do something with it. It isn't like the browser is just going to automatically start rendering it because it's HTML. It isn't going to be HTML. It is going to be data, and we'll use that data to do something to the page, to change it in some way. This will make the page truly dynamic. This is a small thing at first, but little by little, as you get deeper into programming, you'll see how this is an incredibly powerful tool that really liberates the web page into something much more interactive. So let's get down into the nuts and bolts of this. So we basically, when we get this response back, we really can't refresh the entire page. If we did that, we're basically back into synchronous mode. The page has become stale. We shouldn't do anything to it. We should wait until we get the response and then show the entire page at once. So we assume this is used for changes that are either small or perhaps non-visual. Maybe it's a change that's just to the underlying data that will have some implication down the road. And we don't even need to change the page at all. That happens. Now, the data that comes back is not going to be HTML or CSS. It could take a lot of different forms, and when this was originally invented, they used XML. It was kind of one of the reasons that we had this sort of interlanguage between HTML2 and HTML5, which was called XHTML. It was a version of HTML that was described entirely with XML, and XML itself was meant to be a layer above that that could even be used to describe any data you wanted to. These two things were supposed to be the perfect answer to all these problems on the web. It didn't pan out that way. XML is no longer around, and neither is XHTML. They are not used anymore. That doesn't mean you're not going to run into thousands of web pages that still use them. New web pages as they're written are never written in them anymore. XML is still very useful and used in all sorts of places, but generally it's not used on the web anymore, at least when we create new things. There were plenty of things that were created when it was popular that are still around, so you will still see it, but these are legacy systems that you maintain. New systems are never written with XML anymore. So you use that data, you make some sort of update on the page using JavaScript, and we've already seen lots of ways JavaScript can affect the page, can change the DOM, and so we really just have to put those two together. I've got some data, how do I want to put that on the page? And we'll see all kinds of examples of how we might do that in this unit. So how do we actually send that data? I've already told you we don't really use HTML for it. That's not what it's supposed to do. HTML describes content on a web page, not generic sort of raw data. XML was the old standard, but it has flown the coop. It's still around, but it's not used for this anymore. The real answer now is something called JSON. So before we really get down in to see how we're going to initiate these special AJAX requests and receive the responses, we've really got to learn a little bit of JSON. We would be able to get responses from the server, but those responses would be very uninteresting if we don't learn JSON first. Good news is, you actually already know JSON. JSON is nothing new. So let's get into JSON. It's JavaScript Object Notation. We're going to have a lot of acronyms in this particular section, like we haven't had plenty already, but JSON just is a shorthand for JavaScript Object Notation. And all it really is taking what we already do to define an object in JavaScript. So remember that curly brace syntax where we're allowed to define properties and values, where you say property colon value and then comma property colon value, and you go through to as much as you want. That is all JSON is. There's going to be some subtle differences, but by and large that's all we have to do. You take that, you put it in a file by itself, one single object. Now that one single object could be an array with many objects inside it, so really having the fact that it's just one object is not terribly limiting because you have arrays at your disposal, but it is just one thing in there. All of the types and values that you've already learned about for JavaScript are supported here. So there's really just two small differences you have to get used to. First, property names, previously when we defined them in JavaScript, we were always defining them just like they were variable names. In JSON, you have to put them in quotes, and they can be more complex than just variable names. Anything you could put in a string is allowed. So they are actual strings, and you have to put them in quotes. The other thing that you do is when you define it, you aren't actually storing it in a variable or anything. So you have to get used to not putting a variable name or assignment at the very beginning. Let's show an example. I think that'll help this make more sense. Here is a traditional object that we might define inside of JavaScript. Here we're actually defining an array of many objects. We should have seen this in the last, I think it was a couple of modules ago, we saw exactly this kind of data. So what we have here first is an array, and then it contains objects separated by commas. Each object is between the curly braces, and they all have three properties: name, age, and old. And the first one is a string, the second one is an integer, or just a number in JavaScript, and the last one is a boolean. So these are the three things here that are inside of this. We store it in the variable myData, and we could then use it later on in the code somewhere if we wanted to. In JSON, there are just really two key differences. We take the object's value out, and only that. No variable or assignment is used. We just start right with the object, and this is all that would be in the file. We then also have to go through, and everywhere where we had a property, we now need to put it in quotes. And yes, they do need to be double quotes. Similarly over here where we had strings, if these had been in single quotes in our JavaScript, we would convert them to double quotes over here. Now, values don't have to be in quotes. Things that would not traditionally be in quotes, basically anything that isn't a string, doesn't have to be. So these numbers here still don't get put in quotes, and the booleans don't get put in quotes, because we want actual booleans. We don't want a string with the word true in it, or a string with the word false in it. So values are still treated exactly the same way they would be in JavaScript. It's only the property names that need to be put in quotes. The rest of this is identical. So again, just those two subtle differences. Take off the whole variable declaration equals thing, because you're not actually declaring a variable with a name. You're just describing an object's value. And then make sure you put the properties in quotes. So that's the basics of JSON. So you also have a few other supporting functions that you can take advantage of that are just readily available in every browser. These are all part of an object called JSON, all capital, and there's lots of things in there, but the two that you will use time and time again are stringify and parse. So let's assume we've declared a JavaScript object like this somewhere. Object name equals Larry. It's a pretty boring object, but it's an object nonetheless. If I want to convert that to a JSON string, I can just call JSON.stringify. And now I have a string of characters that is exactly what would belong in the JSON file version of that. I could then send that across the internet to a client somewhere. So on the server side, I'd be able to use this to create the JSON data, and then I'd be able to send it off. On the client side, when I receive that data, I'd like to turn it back into an object. What I've got is just a string. That's all a file is just a string of characters. So I could take that string, and that's exactly what the parse function is for. I say json.parse, give it the string. I should get back the exact original object that I had on the other side. This concept is one that comes up time and time again. The general term for this is serialization, although stringification is not that bad of a word either. That's really all a file is. When we store something in a file, it's just a string of characters. And we call that serialized. When things are in serial, they all come one after another. That's S-E-R-I-A-L. And so that's what a file is just one character list after another in a big long list. So when we stringify something, we're really serializing it. We're taking data that was stored in some other way, and when it's stored internally, it could be stored lots of different ways in JavaScript, and we're turning it into something that's appropriate for serial transmission. Serial transmission means you write it to a file on your computer, or maybe you send it out across the internet, and it gets picked up on the other end, where we then take the serial version and we deserialize it back into an object. All those vocabulary words, if they're confusing, don't worry about it. I just sort of put that out there as sort of what the generic term is. Serialization is what's going on here. Let's give all this a try. We're just going to play around with JSON a little bit, have some fun with it, and just make sure you're feeling comfortable with it, because we really can't go any further with Ajax. Well, can't really do anything cool with Ajax until we've got a little bit of JSON under our belt. So I've got an example set up here. Again, I'll put this out there for you guys so you can grab it and do some things with it. And in this example, let's start with the HTML. I've set up just a basic index page that's going to give us the usual kind of blank stuff. For this example, I'm expecting everything will be on the console, so I just say go look at the console. Nothing to see here. A JavaScript file that's empty, and then one that's not. This is just some data that I created for us to play with here. Again, you can grab this from over where you found this video. And what is in here? So we have an array, and inside that array are objects. I keep doing that, don't I? That's because this is always how this data shows up. This is almost always what you're dealing with when you're dealing with data on a web page, is an array of objects. So each object has inside of it 1, 2, 3, 4, 5 properties. It has an ID, which is just a number, and then a bunch of strings, a first name, a last name, an email, and we have this created. So you can think maybe these are all user accounts and they were created on this date. That's possibly what we're dealing with. All of this is just then notated as an array. What I'd like to do here is do some things with this. So first things first, let's go into index.html. And I would like to, in addition to including the index.js file, let's go ahead and include people.js. So So now I've got that data just included in there, just like it was anything else. And so we can come over here, we can say console.info, and let's put people out to that. Now you'll remember the linter gets upset about that because it doesn't know about people, but we can tell it about it. We just say people is a global variable, and then it'll be happy. You'll notice too at the top of people.js I told it that people was exported, so it wouldn't complain about it not being used either. Those are just hints. They're really just comments, but hints to the linter so it doesn't complain. All right, let's go see what it does. So we inspect here, bring up our console. You can see here that when we logged people, or put it out as info, it says it's an array with 10 elements. We open that up. Each element is an object. Let's go into object 2. And you can see here, this is Vicky Herrera, future Merc at yahoo.com. These are all randomly generated names and emails and whatnot. So that was her data, and she has ID number 2. So this is the basics that we expect. None of this should be surprising here. Tony Schmo. These are all stuff we've seen before. So we're just putting it out to the console so we can see what it is. The exercise I'd like to go through right here is I would like to take people.js and actually turn it into proper JSON. So there's a file here, people.json. I'm going to get rid of that. So our goal is going to be, in fact, to create that. So we're going to want to take this and put it in a new file and just modify it slightly so that it looks ever so slightly different. It looks like JSON instead. So I'm going to give myself a new blank file. I'm going to save it as people.json this time. And when we give it the .json extension, it will recognize it as JSON. JSON is a little more strict than JavaScript, so you might see it starting to report errors that it normally wouldn't with just plain old JavaScript. So just be prepared for that. Let's go ahead and drop this in. Now, first things first, there are no comments in JSON. JSON is not intended to be human consumable like code is, so you cannot use these characters in here at all. The next thing, well, we already said, we don't declare variables here. We go right to the object itself. So all of this needs to go away. Then we're on into the point here where we now need to start thinking about and converting all of this into something that is JSON compatible. There's a basic process that we're going to go through to make that happen. So I'm going to do a lot of find replace to do all of this as quickly as possible, just so we can get to the end result. First things first, I mentioned before that single quotes are not okay in JSON. Everything has to be double quotes. So I'm going to find all single quotes and convert them to double quotes. Search for single, convert to double, replace all. Yeah, things are looking a little bit better now. And now what's the other thing we always have to do? There's kind of two key differences between the two. Little things like single quotes aren't supported, so you have to use double quotes. But also, we take off the variable declaration. The other thing is every single property must also be in quotes like it was a string. So doing that is not too hard here. Basically, we're going to want to find each of these properties and then replace them with themselves surrounded by quotes. So there should be 10 of them every time. I'm going to do this and always do find to make sure it finds the 10. And I'll tell you what, just to make certain we're getting it, let's include the colon. So ID colon is now going to become quote ID colon. Replace all. There we go. Now that's not highlighted in red. It's happier with that. Next up is first name. Okay, I found 10 of those. Good. And then we replace it with the same thing, only it's surrounded in quotes. And we keep going like so. And there we are. So at this point, we have defined everything. We should have a well-formed JSON file. There's only one error remaining, unknown character. So JSON is always going to be one very long statement. Now, it's always going to be separated onto multiple lines wherever it's appropriate to do so, like at the commas, or at these delineators like the open and close braces. But it will always just be one very long line. And so you don't need a semicolon. The semicolon is basically not included in JSON. So that's another thing you would get rid of. So when you have an editor like Atom at your disposal, it's pretty easy to just work through JSON and create it like this. So there we are. We have everything right here now stored in a JSON file. Now there's a few things we can do with this. So we've got people.json all defined and ready to go. It's worth noting, and if you didn't do it, make sure you declare people.json inside your public folder. Because it's in public, that means it will be served like any of the other files that are in here, like index.html. So if you wanted to get to it, you can come up to localhost 3000 / and let's put in people.json. And it actually comes out and tries to give you this file. And it just grabs it and receives the file like you'd expect. So it downloads it, in fact, and you could then open it and do other things with it. So accessing it directly is not necessarily useful. It even warns you here that, hey, this kind of came down in a way that you maybe didn't intend. It came down as an octet string. That's actually just our really simple local server, our PHP server, not really interpreting JSON very well. This is all we really want to do for right now. JSON isn't terribly useful when we just write it out like this. But one thing we could do with this that would be interesting would be to bring it over and actually put it directly into our code. So I'm going to copy this exactly like it is. I'm going to come back to people.js. And I'm going to create a new variable, people.str. And I'm going to put this inside of the backtick quotes, so those ones we usually use for string templates, and create a big long string here that is exactly the contents of what we created in the JSON file. So it goes right in, grabs this, and then it comes down through all of this. Now, because we use the backtick quotes, the one that's up on the tilde key, it will allow us to have new lines. It won't get upset about having quotes in there. Everything should be nice and happy. So people.str is now the JSON version of this. In fact, why don't we call it that? People.json. Let's call it that. This is the JSON string of what we created before. So we can say now, let's export people.json as well. Now let's come back to the JavaScript here and see what we can do with that. First of all, let's log it. Info people JSON. And then we're going to have to make sure to tell it that it exists, that it's a global people JSON. And it's happy. Let's save that. And here we are. So the first one is still our array of 10 objects, like it's always been. That's the line 2 is logging that. And then line 3 is logging this. It's just a string, a big long string, and it's not an object. If it were an object, we'd be able to interact with it just like we were up here. So now we can use things to turn this into something. We'll call this myPeople equals JSON.parse, and we will say people JSON. So this will now go through and try and convert this string into an actual stored object. And let's output that. We'll output myPeople. If we did this right, it should look exactly like people did. So there we go. Here's the first output, is that array of 10 objects. Here's the JSON. And then here it is after being parsed. It's exactly what it was before we turned it into JSON, assuming you did it all correctly. We can even go back again. We could, this is the other thing. You should really never have to write JSON yourself. If you have the JavaScript and you want to see what it looks like with JSON, there's a function for that. I already told you what it was. It's stringify. We can print that to the console. We'll say json.stringify, and we're going to say people. We stringify the array. So yeah, we bothered to do it manually. And that wasn't that hard of a task. It was just a whole lot of replace alls, right? Here, we'll let JavaScript do it for us. And just to avoid clutter here, I'm going to take out all these other bits and pieces. And let's just look at that one result. And there it is. It's a big long string. It's not as nicely formatted as ours was, but it's exactly the same, other than white space, as what we had created manually. You see the array, then you see each of the objects here, comma, object, comma, and so on and so forth, and then the array closes. Notice that all of the variable parameters, excuse me, the object parameters or properties are in quotes, but each of these are not. Only the strings are. The strings are in quotes, but the numbers are not. If we had booleans, they wouldn't be in quotes either. So primitive types are not listed that way. Only strings are.